Hello everyone and welcome to our Terracotta webcast series. Today we're going to talk about the challenges and opportunities big data poses on e-commerce site performance and how big memory significantly improves that performance, giving you speed, scalability, stability, and most importantly drives revenue growth in a cost-effective manner. I'm Ransom Williams and I've been working with customers to implement and improve their e-commerce sites since the late 90s and have worked with many of our largest and most successful e-commerce customers here at Terracotta. Joining me in this discussion is Manish Patel, our solutions architect who has worked with many of our largest e-commerce customers to implement their Terracotta solution.
Hi everyone.
So a quick overview around timing. Our presentation will run about 20 minutes and then we'll take questions via our instant message system. At any time during the discussion, just type in the questions in the questions window or the chat window. And we'll do our best to answer all the questions at the end of the webcast. Now let's review the agenda. The purpose of today's session is to break down some barriers to new thinking and understand what is possible today, how big data in real time can change your approach to making your brand the standout in its category. So we're going to start by talking about a few of the e-commerce challenges today, then move on to the in-memory revolution, talk about 5 ways to boost e-commerce performance, and then hit some customer success stories, and then finalize with some Q&A today. So success for Manish and I today is breaking some barriers, providing some new ideas, and showing different approaches to take your business to the new level. So here are some interesting stories, but what do these stories tell? First of all, I think we're all aware that we are still in a time of rapid growth within e-commerce. Customers' expectations remain high and are probably even increasing. The fact that a vast majority of shoppers will abandon their cart if a site is slow. The interesting thing and the dynamic thing is that as mobile devices have proliferated, shopping behavior's changed, and now we have to deal with not only people from a web browser on a machine, on a computer, but any kind of device that will be coming in. Then lastly, it's really talking about what opportunity that big data provides. The statistic we put here is an increase in profit margin, but as we take a look at how big data can be incorporated into e-commerce environments, we really need to take a look at all of these things from the flip side. Because, do these statistics really tell the story that we need to be prepared for? In the early days of e-commerce, we talked about capturing eyeballs. And today, it's really about engagement. It's about fun. We need to delight your customers with their experience, make it really interactive. And that's where big data becomes the real game changer. So if we take a look at these from a different perspective, what if we have to create performance capacity not only to be fast, but to make it interactive, to utilize that big data to make it interactive? Rather than worry about response time is fast enough to keep the eyeballs, focus on enriching the experience to make it truly interactive, where performance is really going to be a difficult challenge. And how do we leverage these mobile devices to make a better experience? For example, an in-store experience, an interactive experience. How do we incorporate things like Twitter feeds, location data, and to leverage instant promotions? And then once the experience is done, how do we push that data back into Hadoop for the analysis to make that next experience even better? So I think that the important thing is understanding, does your infrastructure or application scale today for today's applications? But the real question is, can your infrastructure scale to incorporate big data applications that the business is demanding? Big data is really about converting those millions of data points into real usable information to enhance your customer experience and to grow the business. And I know the business people are talking about ways to make this a much more innovative experience, to engage the customer, to enhance the brand, and we need to be prepared for it. So why can we do this now? The base requirement, of course, is to provide fast and always available information. But now we need to incorporate big data into the mix to enhance this business experience, to enhance the customer experience, and also enhance our brand. So the difference now really is with the proliferation of new technologies. Proliferation of 64-bit architecture is almost complete. If you don't have it in place today, you're probably planning on finishing it up pretty soon. The other big change is the fact that we've brought commodity-priced multi-core hardware with huge memory footprints. Today, the price curve's right around 512 gigabytes, but with prices dropping at 30% a year, we'll be a terabyte very soon. So big memory is really the thing that ties us together, that enables this massive leap to in-memory storage. And we call that the in-memory revolution. So what does that really mean? I don't know if it's exactly a law of physics, but we all know that access from RAM is a lot faster than from disk or a database. It's much faster. If you take a look at the systems of today, the vast majority of the data is accessed via database and via disk, with a small portion of it through traditional caching systems. When you start to take a look at the way that we need to modernize these applications, this system can be slow, it is expensive, and it can also be difficult to scale once you get to the tipping point of integrating big data in a real-time manner. As you modernize your system, what we're suggesting here is that we put the vast majority of your hot data set, 90% or greater, into memory, relying on database calls for only a small portion of the times that you access data. So we move from relatively slow or acceptable to ultra-fast. We'll talk about the expensive part of this, but we have examples where our customers have dropped their costs dramatically through requiring a lot less hardware, fewer database licenses, and a lot less management and oversight from DBAs. And the other part of this is that once we get to a certain point with a database, it becomes the choke point. And if I look back at my experience in the market, in taking a look at scaling systems, the database is typically the bottleneck. When we put this data into memory, we get outside of that bottleneck and are able to access massive amounts of data directly from RAM. So scale's always been a big challenge. Java is the right technology for many reasons, but it has some limitations. We all know about heap limitations for memory sizes. If we get the heap size too large, we get into GC pausing. If we want to get rid of GC pausing in large heap size, we have to do extensive tuning using our most expensive and experienced people. And the traditional way to scale first-generation caching solutions was to scale out, and sometimes scale out massively. For example, if you wanted to have a 1 terabyte in-memory system, and you wanted to keep, even in a 64-bit system, you want to keep the heap size reasonable, let's say 5 gigabytes, you would have to have about 200 JVMs to support this 1 terabyte requirement. With big memory, you can reduce the complexity down to a handful of JVMs, 5 or 10, depending on other considerations. So Manesh, could you take us through this slide of the architecture and tell our audience about how we can scale up and scale out, eliminating complexive and massive and potential massive scale out?
Yeah, absolutely. In general, when it comes to in-memory data management, Terracotta's big memory is really a major breakthrough. So the ability to both scale up and scale out. With big memory, you can scale up and store massive amounts of data within your Java process, RAM. So what I mean by that is, for example, on a single JVM, imagine being able to store your entire product catalog or millions of customer records all in process. What big memory does is that it stores data off heap. The beauty of this is that you can keep your Java heaps, very small, so you get predictable latency, and the data gets stored all off heap without triggering those infamous, GC pauses. Scaling up with big memory also means that you can maximize the memory use per server. So on a single JVM, you'd be able to utilize, and scale all the way up, fully maximizing your commodity servers. In fact, we've tested this by scaling up to 2 terabytes on a single JVM, and as we did that, we saw consistent, predictable results all the way up. And then, when you get to a point where you actually do want to scale out and distribute your data across a cluster, for example, big memory allows you to do this without any changes to your application. This allows for simple and predictable scalability up to tens, maybe even hundreds of terabytes. So big memory provides scale up and scale out. And the key here is it does so while providing predictable low latency access to terabytes of data across a highly distributed application. So in that sense, like I said, it's really game-changing. So now let's see how this architecture allows us to map and address some of the challenges that that are out there in the business today. Ransom, you want to take us through that?
Okay, sure. So, I think that the thing that we presented up to this point is that in-memory data management offers a huge advantage for e-commerce sites to scale and give good performance. Let's look at 5 ways big memory can improve e-commerce performance for a superior customer experience really at any scale. Many of our customers engage with Terracotta because they're missing SLAs, which are set to provide a good customer experience. As they migrate over to an in-memory data solution from Terracotta, accessing data from memory can be 100 times faster. With Terracotta, only the first call is done from disk. The remaining information is always pulled from memory. And in memory, you're calling a Java object, so it's already ready to be acted upon by your application. So for example, if you have a call, if you do a specific call thousands of times, the first time you do it from disk in the database, the rest of the times you're doing it from in-memory, which gives you hundreds of times faster data access. Mm-hmm. Another reason our customers look at Terracotta is scale. Not only do you get an increase in predictable, it's not only from a predictable demand, but the issue really comes when we have unpredicted spikes in demand.
Yep.
If your normal traffic is hundreds of thousands or tens of thousands of visitors and it doubles or triples over a short period of time, and you're now accessing all this terabytes of big data, this really gets into tens of thousands, if not millions, of transactions per second. And a great example of this is one of our customers that had a mission-critical application for the business. And so they put in a Terracotta server array with lots of big memory to be able to access this data very quickly. But due to the critical nature of it, they put in a very expensive Exadata system actually as the backup to their big memory implementation. This Exadata system cost 10x more than the Terracotta systems did. To do some further testing, once they got it ready for production, they ran the same simulation with Terracotta off, running directly off the Exadata system. Not only were we 7 times faster than the Exadata system, but our performance characteristics were provided linear response times across multiple different demand characteristics, whereas Exadata provided very spiky performance characteristics across these different demand types. So we're able to scale, we're able to handle those peaks, we're able to handle all the information coming through with very low latency and very consistent traffic back to the customer. Another key thing for our customers in really hitting the performance maximization is the ability to provide stability throughout these loads. And I touched on this in a little bit in the previous slide. What we want to avoid is that as we get into loads that exceed our normal capacity, we want to eliminate any kind of timeouts from a database or any kind of slowdowns. As we offload the database and bring this massive amounts of information into memory, we eliminate these bottlenecks, and with our customers, we're providing 5 nines of availability in a very stable environment for our customers. The other thing is that as we get into this kind of scale, we've seen some of the larger companies being able to do this much ahead of the curve than many of us are able to afford. Not all of us have the budgets that Amazon.com does, or places like eBay or so forth. So we need to be able to do this in such a cost-effective manner. I've already touched on the fact that as we were able to deliver much better performance and much more consistent performance than an Exadata system that cost 10x what we did, we were able to do so without proliferation of a lot of web application servers because we were scaling up before we scale out, and the reliance on costly databases or mainframes goes down. So we're able to run in many environments with a lot fewer servers. The fact that RAM is becoming a lot less expensive on a yearly basis. We're able to save on hardware, software, and I think also very importantly is the fact that we're able to save on the administration of these very complex databases. And then the last thing, we kind of touched on this at the beginning, whereas as the business looks for new ways to engage the customer, to enhance the brand, to be able to bring customers in so that we can actually beat that 45% growth over the next couple of years, we need to have the ability to meet these new business requirements. We need to be able to have new capabilities that engage a customer, not only from a computer, but from mobile devices, be able to do spot marketing promotions, be able to direct people to the right place, either on the site or in-store for an in-store experience. All of these things require innovations that will increase your sales. And the real-time services that big data can provide to enhance this personalization offers a tremendous opportunity. It gives you speed for mobile users and the scale that marketing requires to drive the business forward. So the other thing that I think that's really key here is that this is not a new solution that we're just bringing to market. This is something that's been shipping for several years. Matter of fact, the Terracotta server array that backs us up is one of our most mature products. It's been around for a very long time. So we're able to power sites that have thousands of products, sometimes tens of thousands of products, with hundreds of thousands, millions of registered users, millions of daily visitors, and billions in annual revenue. And you see the icons at the bottom. If in your daily course of business you've booked a hotel reservation, you've booked an airline reservation, you've used your credit card, you've bought tickets online, right now you are using the Terracotta system because we are cornerstones to the technology that delivers those services today. So what we'd like to do now is move over and have Manesh talk about a couple of our exciting use cases that we've had in the last year or so, talk about what we saw as we came into that use case, and then how we solved it with Big Memory.
Great. Thanks, Ransom. Yeah, absolutely. So lots of success stories. A couple of them I'll touch on. The first one deals with this is for a Fortune 150 seller of athletic footwear and apparel. And it's probably one of the most recognizable brands on the planet. And this particular company was very successful. They were experiencing some really great increased revenue from their e-commerce site, which hosted 7,500 products or so, and sales from just e-commerce were topping over 340 million. And because of this, the company, needed to ensure that it could continue, that it could support continued growth without overloading their core back-end systems. And so the challenge here was that product data requests, which were driven by high volumes of shopper activity on the site, ended up starting to tax the search engine that was backing the site, as well as the various services that were backing the site. And as a result of this, the page load times, search times were heavily impacted. The company needed to continue delivering a high-performance site without having to further scale out its back-end services. And like many e-commerce sites, the online store of this global brand pulls data from various sources. These include disk-bound databases, various web services, and they also have this search engine that sits back there. And as transaction volumes grew, so did the load on these services. And more sort of critical was that large spikes in the traffic due to promotions, product releases, maybe a famous athlete wearing something, maybe something very unexpected like that would cause these large spikes in traffic, and all of that jeopardized the stability of back-end services and ultimately the performance of the e-commerce website. The athletic company quickly realized that it needed to protect itself from these spikes and continued growth, and the only way to do that was with an in-memory data management solution. So this company opted to have a highly available Big Memory Max deployment And in this scenario, they have 96 gigabytes of in-memory as their current configuration. They are actually in great position because what they have here is they have a gigabyte local to the 32 instances of web app servers that they have, and 64 gigabytes of big memory for distributed access. And you know, the great thing here is that they're in position to continue to scale very easily without making any application changes. Now, after going live with big memory, some of the value that they've seen. So since going live, they've actually been able to reduce the overall load on these various back-end systems by 40%. And a whopping 90% of the product data requests are served directly out of big memory. So microsecond, millisecond access directly out of big memory. Only 50% of the search requests end up hitting a search engine. And as an added major benefit, big memory has improved the overall experience for online shoppers. The ultra-fast data access has resulted in faster page load times, shortened searches, or shortened time to search, and all of this has well exceeded the customer's expectations. The big memory not only helped this company avoid the expense of scaling out back-end servers, but it's also protected them, given them stability, and protected their the systems that support the website not only support the website, but are also a core component of other pieces of the business. And so thanks to big memory, this major athletic footwear company is well positioned to keep e-commerce sales running and jumping higher. And in this case, it's not the shoes, it's got to be the big memory. Let's take a look at the next success story that I have here. This one deals with a Fortune 100 shipping company. This is a $30 billion .com company, and every day this particular shipper's website handles more than 32 million requests to track shipping, tracking requests, 32 million. And for the world's largest package delivery company, this huge volume of traffic provides a big business opportunity. And this leader in logistics wanted to increase customer satisfaction and sales by serving up location-based content to users that are actually logged into the site. So as an example, imagine the website can give you an alert if you're trying to ship something from a particular location or to a particular destination where there may be a weather storm or something like that en route. They can also be able to display market-specific discounts and product offers. All of these things sort of designed to help boost revenue. And the challenge here was being able to present this location-based offers or locally relevant information to a global user base at speeds fast enough to meet strict performance standards. Right? So matching content to customer required time-consuming calls to various multiple databases. And as a result, data retrieval times were 4 times slower than what the service level agreements that were in place were. So not only was the shipper falling short of their SLAs, the company also risked upsetting customers with a subpar online experience. And to kind of fix all this, they decided, again, they needed an in-memory data solution to do this. And in this particular case, they had conducted a rigorous evaluation, and they had 3 alternatives that they tested with. One was obviously Terracotta Big Memory. IBM Extreme Scale is something that they also evaluated, and so was Oracle Coherence. Immediately, Terracotta stood out because of its ease of use. The customer was actually able to breeze through the proof of concept in just a few hours with big memory, while the competing products required days, some of them even weeks. The more impressive thing was big memory's ability to perform compared to the competition. It was just an unmatched in terms of speed and performance. And this shipper ended up going live in late 2011, and in that original implementation they were able to store 90 days of customer data in memory. And they'd been so successful with that initial use case, once they went live with big memory, they were able to slash the time to serve market-specific content from 900 milliseconds to 120 milliseconds. And that was a dramatic 85% acceleration there. This overall faster speed has allowed them to consistently not just meet but exceed their SLAs and present location-based relevant offers and alerts without jeopardizing customer experience. And in fact, they've been able to take that and build onto that particular platform, provide more offers, provide more features to their customers on their website, making it just enriching the overall experience. And in fact, this particular use case and this group was so successful that they've decided as a company to adopt Big Memory as a corporate standard for their in-memory data management solution. The IT enterprise architecture team is now educating other groups within the larger organization of, asking other groups basically, what can Big Memory do for you? These are some of the, there are many such success stories, but these are some of the two that dealt with e-commerce. So Ransom, anything you want to add to that, or?
Nope, that's good. Thanks very much for going through those use cases. It's pretty exciting ones, and obviously we have a whole lot more than that we can talk offline with folks about.
Yeah.
So basically, in summary, what we've really hit on is the fact that we're in changing times again. The fact that big data can have a real big impact on enhancing the way that e-commerce works and enhance that experience for customers and make that brand just a whole heck of a lot better. So in summary, we talked about speed, scale, and stability, and the fact that we can bring these things in a very cost-effective manner. And the ultimate part of this is that our systems are going to be able to help your business people drive the growth goals and the customer satisfaction levels that they want to deliver to your customers. So okay, that's the material we wanted to cover today. But before we get into questions, we wanted to let you know, for those who missed some of the webcast, we'll have it available on our site, and we'll send out an email with a link to that. So okay, let's dive into the questions.
Yeah, great. Wow, there's a lot of good questions here in the list here. Okay, so let's take the first one here. It says, what was the largest challenge faced during any of your e-commerce deployments? Oh, that's a great question. Okay, so the first thing that comes to my mind is actually we had a situation at a very large hotel chain that had implemented Big Memory, and interestingly, after they had gone live, their Oracle rack system, which backed the application, went down. And these things tend to happen, but it went down, and it went down for an excruciating 18 hours. And during that time, they were able to actually serve all of their application requests just by the data that was stored in Big Memory. So they were able to maintain stability and uptime, continuous uptime with the help of Big Memory. But that was something that was interesting there. Let's take a look at the next question here. So the question here says, do you support petabyte scale Hadoop clusters? Interesting. Ransom, you want to touch on that? And then I got some things to share with that too.
Yeah, sure. So yes, so absolutely support petabyte scale Hadoop clusters. So I think the important thing to look at here is the fact that obviously today you're not going to put petabytes of data in memory. The real critical piece here is that you want to store your hot set of data in memory. And so whether that's gigabytes, hundreds of gigabytes, or terabytes, you can support petabyte scale Hadoop clusters. And so, and actually we're delivering today connectors in that provide the ability to take data not only once a Hadoop job is done, but actually on the fly while the Hadoop job is running. It can deliver data, and even before it saves it out to HFS, can populate Big Memory directly through Terracotta's Hadoop input connector. And in the same way, we can, if we're generating results that need to go back out to the Hadoop cluster, we've got a connector that can deliver that data out of Big Memory directly into the Hadoop cluster.
Right. Yeah, that's what I was going to touch on, the input and output connectors that are available with the Big Memory Max 4.0 release. Yep. Great. So then we have another question here. How does Big Memory integrate with leading e-commerce packages? You want to touch on that?
Sure. Yeah, sure. So the question is specifically to packages like IBM, ATG, and Hybris.
Yep.
So I think one of the key characteristics of our solution is the fact that we're very open. We're API-based, and we're simple get-put mechanism to fetch and retrieve data.
You got it.
So what it really comes down to is how open is the e-commerce package that you're utilizing. If they allow you to do get and put out of the system, then it should be a fairly trivial matter. Many of our customers are now implementing Terracotta in a way that we call in-memory as a service. And in-memory as a service is another way that you could access big memory, a big memory solution from these packaged applications.
Yep. Yeah, exactly right. All right, great. So let's see, another question here says, can you elaborate on the complexity and slowness aspects of coherence? Okay.
Well, I always love to hear that one. So if we go back to the architecture slide and the fact that when you're doing in-memory on a heap-based system, like the first-generation technologies, and we have a first-generation technology with our cache API, so it's similar limitation. If you're going to put information into memory and you're going to use a heap-based system, you're either going to have to make your heaps very large to scale up, or you're going to have a lot of JVMs.
Right.
And I think the example I used was a terabyte, and if we keep a reasonable sized heap size of about 5 gigabytes, then we're talking about 200 JVMs. So when we talk about complexity and slowness of a competitor that's a first generation or traditional caching technology, it's really those limitations. And then there are other things that become involved in a peer-to-peer environment where there's lots of
there's a lot of data replication.
Exactly. So once you get into the large number of JVMs, then there's excess overhead due to that.
Oh yeah.
Okay.
Great. So we have one final question. Let's see. It says, how do you define ultra fast versus fast? I like that question.
It might be a little tongue-in-cheek, huh?
Well, so Ransom's fast, and I'm ultra fast. No, I'm just kidding.
Yeah, I think this really comes down to, as you are looking at the way that we do things today versus the way that we need to do things going forward as we incorporate the enhancements that big data can provide in your e-commerce system. So nobody's saying that databases aren't fast. I mean, let's not kid ourselves. Databases are fast, but they do become a choke point at some point, and many of the customers that we talk with have already experienced that just
like
today, even without big data, right? So I think that when it comes down to disk-based database solutions versus in-memory Java object solutions that we provide, you're going to have that ultra-fast, that extra edge to be able to pull the massive amounts of data in that are going to make your applications even better.
Absolutely. Yeah, great questions.
Super, good. Okay, well that was a great list of questions. Thanks again for your time, and we'll look forward to working with you around the Terracotta Big Memory solution. If you have any questions, feel free to email or call us. My email address is listed on the slide. And if you send me a note and either just want to have a conversation or set up a demonstration, I can get you to the right person within Terracotta. So again, thanks everybody for your time, and have a great day.
Thank you. Yeah, thanks everyone.